we'll extend the concept of limits from last time. Right. So what did we learn last time was, if I say limit x tends to, let's say, 0, and I say x plus 1, and I say, okay, find me the limit of this function when x tends to 0. This function is f of x, obviously. So you just blindly plug in x equals to 0, and you say 0 plus 1 equals to 1. This 1 is called the limiting value. Limiting value, where this function will approach. So if your f of x was x plus 1 and you're finding limit of f of x, x tends to 0, which is x plus 1, the limiting value is 1, right? Now, let's take an example of the rectangular hyperbola. So the rectangular hyperbola has this kind of graph, right? So remember, we're extending from where we left last time. X, y, negative x. The rectangular hyperbola has the function is what? F of x equals to 1 over x, right? This is how the graph looks like. Now, as x approaches 0, what will be the value of this function? As x approaches 0, that means you are on the y-axis, correct? You are here on this line, because on this line your x is 0. So tell me, if your x is approaching 0, obviously it can't be 0 because this function is not defined, because they're asymptotes. What will be f of x? What will be f of x? Think about it. This is just a brainstorming, a bit of it. Now, you see, the challenge in this particular question is x is approaching 0 from two sides. One is here and the other one's here, right? So this goes on. Somewhere the gap will start to close, and obviously it will start to approach 0. So this is going towards the positive infinity of y, correct? And what is happening here? This is approaching, the function is approaching the negative infinity, the negative side of y. Did you get my point? So here, the limit is just not very straight away that I say, okay, limit x tends to 0, 1 of x is something. No. Then, in this case, I've got two varieties of that limits, the approaching 0 problem. One is telling me, okay, you throw positive infinity value, and the other one's throwing a negative infinity value. So in this case, when x is approaching 0, I am approaching 0 from this end, which is my right hand side, correct? And this is approaching 0 from the left. So therefore, you have two different limits here. One is called the left limit, and the other one is called the right limit. So how do you write it? How do you express it? So you will say then that if now this is f of x, so I will say limit as x approaches 0 from the negative 1 over x is approaching negative infinity. You see here, I'm talking about this. When you're approaching 0 from the negative end, this is the negative side of x. You're approaching 0 from the negative side of this side of x. What is happening? You are going to negative infinity. Did you get it? Yes? So this is called the left limit. Left limit. When you approach the number, your limiting number from the left. And obviously what's happening here? Limit x tends to 0 from the positive side, 1 over x tends to positive infinity. Does that make sense?
Yeah.
Romeo?
Yeah.
Yeah, 100%. This is the right limit. Make sense? The left limit and the right limit. I'm talking about, if I take a different color, I'm talking about this end of the arm, this arm of the graph. Right? I can also talk about this side of the arm, this arm of the graph as well. Let's write the limit for this one. Can I say limit? Let me know if it's not clear. Limit x tends to negative infinity. It's going to the negative infinity. 1 over x, or my f of x, tends to 0 positive. 0 positive. Sorry, 0 negative, my bad. 0 negative. This is going towards infinity, the x, and the gap is becoming smaller and smaller and smaller, but it still sits underneath the x-axis. Therefore, y will be 0, slightly, very, very close to the negative side of 0, approaching 0 from the negative end. What does that mean? This means something like a negative 0.00000000001. For example, this is what it means. This could be one of the values here. What about here? This side. Limit x tends to positive infinity, f of x equals to 0 positive. Who hasn't understood this one so far? Slightest of the doubts. Ayushka, is this clear?
Yeah.
Ryan, is this clear? Chris, is this clear?
Yep.
Romero,
Yeah.
is this clear? Don't flip the book, that's fine. Right? And since you opened the book, can I just grab the book for a second, please? All good? Now, let's talk about something called, shall I take this off the board? Who understands the concept of continuity? Who understands the concept of continuity? We'll do some questions and that'll make more sense, okay? We'll just put this into the questions and that'll make you more sense. I'm just drawing the, it's important to understand the thought process behind what are we going to do in the question. Who understands continuity, please? Anyone? Have you heard about continuity before? Have you heard about it? You don't know. Have you heard about it? No. Have you heard about it? No? Nothing? All right. Continuity means something which is stupidity, but something which is continuous. Continuous means without any break. And we are talking about continuity or being continuous with respect to the graphs, with respect to a function. So for example, if I say y equals to x plus 1, y equals to x plus 1 would be what? Something like this, no? Something like this. And this will go towards negative infinity, this will go towards positive infinity. Domain and ranges are for both of them. Correct? This function, if when you look at the graph, is there any breakpoint, or is this just like a one single flow of line? It's just flowing through, right? There's no breakpoints. This function is continuous. Now, if I just change it, and let's say I draw another the graph. Let's say that value is 1, that value is 4, that value is 6. Hypothetically, you've got this graph, let's say. We'll talk about this, what does actually mean. Do you feel that this graph is without any breaks? It has one break in it, right? That's where it is. This is the break point. At x equals to 1, the graph breaks. Correct? There's this gap here. So this function is not continuous. In very, very layman terms, plain English terms, this is what continuity means. So continuity at any given point in time means that on the graph, continuity basically you can check at any point on the x-axis. So if I say, okay, so for example 1, 2, 3, 4. If I say, okay, let me check this graph, is this graph continuous at 1? So you can say, yeah, probably that's the value of y. Continuous. Is this graph continuous at 4? X equals to 4, yes. That's the value of y. Easy. Here, is this graph continuous at, let's say this is negative 1. Is this graph continuous, the second one, continuous at negative 1? You can say yes. That's the value of y. Is this graph continuous at 1? That's the problem. When I draw, I get two values. And I say no. This graph is not continuous at 1. So continuity is always with respect to a value on the x-axis. So if you can find, hear me out loud and clear, if you can find a value of y for a given value of x, the function is continuous at that point on x. Does that make sense? Yeah. At x equals to minus 1, is this continuous? Yes. At x equals to 0, continuous? Yes. At x equals to 1, no. There's a problem. This is what continuity means, right? Let's do an example, probably a question that will make it more sense. Now, if I were to now connect the dots between limits and continuity, the function is continuous. The function is continuous if limit, I'm fine if the function is continuous, if I have to find that whether the function is continuous at a value x equals to a or not, then I will say limit x tends to a, f of x should be f of a. This has two branches, the left limit and the right limit. Both should be equal. If both are equal, I don't have to write them separately. I should just write it like this. Does that make sense, Aisha? I'll do a question that will make a lot of sense. Theoretical, at times maths becomes boring, right? At times it starts to fly around, right? But in its very, very simplicity, does that make sense? So whenever I write limit x tends to 0, that means and f of x, let's say f of x is any damn function, right? Let's say this is the f of x, right? So f of x is what? So if plug in 0, it is 1, which actually means that limit x tends to 0 negative, f of x will also be 1, and limit x tends to 0 positive, f of x will also be 1. There won't be any difference. And that is why I don't care when you have this value. So I don't write about these two values. I don't write these two expressions at all. This actually just means the function is continuous. If you get a different value here and a different value here, then the function is not continuous. Let's take